In this lesson, we're going to take a look at the circles and how to find the area of a circle. So we're going to figure out how to get the formula of a circle and then apply that formula to calculate area. So if we want the area of a circle, if we use the formula for the area of a triangle, notice how we're not getting all of the area. Well, what if we increase the number of sides and we do the area of a square? We get closer to getting the area of a circle, but we still don't quite have what we need. What if we do the area of a pentagon? Again, we're getting more of the area that we need, but still not quite enough. Let's make more sides. So area of an octagon. Again, we're very close to the actual area of a circle, but we're still missing some little bitty pieces. So do a dodecagon. Again, there's such a minimum amount of area missed, it's almost the exact area. So we'll go to an icosagon, which, as you can see, almost looks like a circle. There's so many sides, but it's not quite a circle, so which means it's not quite exact. So how do we get the exact area of a circle? Well, we can start with the area of a regular pentagon or regular polygon, and instead of doing perimeter, remember the perimeter of a circle is actually called a circumference. So here we have a formula for the area of a regular polygon, 1/2 AP, where A is your apothem and P is your perimeter. Well, the apothem and the radius for a circle are the same thing, so we can instead of saying apothem, we can say radius. And then the perimeter of a circle is the circumference, or C. Well, we know that circumference is found by using 2 pi r. So instead of saying C, we're going to say 2 pi r. And then we'll simplify. 1/2 times 2 is just 1. And then we have r times r, which is r squared, and then pi. And that's how we get the formula of pi r squared for the formula for the area of a circle. So our theorem for this lesson is the theorem for the area of a circle, and it's pi times the square of the radius. A equals pi r squared. So let's do a practice problem. Let's say we want to find the area of the shaded portion of the figure. The entire thing is shaded. So it looks like we're going to use the addition theorem, and we're going to divide it into 2 pieces. We're going to have this rectangle, then we'll have this rectangle, and then we'll have a half circle. So let's start with the half circle. This isn't a full circle, it's half a circle. So we know that the formula for a whole circle is pi r squared, but since we only want half of it, we're going to do half of pi r squared. And so first we have to figure out, well, what is the radius? Well, this entire thing is 7, and this piece is 3, which means this piece is 4, which means the radius is half of that, so our radius is 2. So we get 1/2 pi 2 for radius squared. And 2 squared is 4, and half of 4 is 2. So that's how we get our final answer of 2 pi. All right, let's do this rectangle. We already said that this portion here is 4 because 4 plus 3 equals the total of 7. And then they tell us that this piece is 2. So now we have our base and our height. So 4 times 2, which gives us 8 for this portion. Now we're going to do this portion. So we know that this is 7. And then we also know that this piece here has to be 4 because this piece is 2 and the whole thing is 6. So if this piece is 2, then that means this piece is 4. So we have 4 times 7 for the purple rectangle. And 7 times 4 is 28. So now we know all the pieces. So the addition postulate says that we can add those areas together. So 36 plus 2 pi. And we end up with 42.3 square units. Go ahead and try some problems on your own.